if you have ammonium chloride, for example, you have ammonium chloride, you want to decompose it. After you have decomposed it, what do you form? You form ammonia and hydrogen chloride gas. So if you cool back the ammonia and hydrogen chloride gas, so you get to form the reactants. You got to form the reactant, that is what? Ammonium chloride. So this means the reaction is reversible. The reaction is reversible. So another example I give here is ice. When you subject ice to heat, so what happens? It melts to form liquid water. If you continue heating, you know, we can be the boiling point of water is at 100 degrees Celsius. So if you continue boiling the water, it starts to form vapor at 100 degrees Celsius. So that you can form ice. You can melt ice to form water. Again, you can further heating of this water can form vapor. So again, you can cool vapor back in what you call condensation. You cool. When you cool vapor, what do you form? You form water. You form back water, and again, further cooling, you form ice. So this means as you move from the reactants to the product, you can again form back the reactants from the product. This means the reaction is reversible. The reaction is reversible. So, depending on the conditions applied here, and the conditions I said, we have pressure, we have temperature, we have catalyst, we have concentration. Therefore, you can attain the state of balance. You can attain the state of balance, and the state of balance here is equilibrium. The state of balance is equilibrium. Those who are doing physics, you have heard about this equilibrium as the state of balance. So, I want to say this. This equilibrium comes about that if you form, for example, I've used ice. Ice can form water. When you subject it to heat, you can form water. And again, if you cool this water, you can form back the liquid, the ice itself by cooling. So it means that the reaction is reversible. If the reaction is reversible, therefore means that forward and backward reaction is occurring. Forward and backward reaction is occurring. What I mean by forward is you melt ice to form water. When you melt ice to form water, that means the forward reaction is attained. What if backward reaction comes in? So backward reaction is when you cool water back to ice. You cool water back to ice. So that means the reaction can proceed both forward and backward, depending on the conditions applied. We shall discuss about this one later. I want to move forward to what we call dynamic equilibrium. Dynamic equilibrium is where you have the reactions. The reaction proceed forward and backward at the same time, simultaneously. So this means the reaction. The reaction rate is occurring at the forward and backward reactions is taking place at the same time. This means we call it dynamic equilibrium. So equilibrium, or what you call state of balance, is represented by an arrow. It's not a full arrow, but an half-based arrows. Okay, so I can say the full arrow represents a reaction whereby it cannot attain equilibrium. For example, if you have ammonia reacting with hydrogen to form okay, let me use ammonia. Let me use, for example, magnesium oxide plus water to form magnesium hydroxide. That reaction is not reversible. You can't reverse it. So you use just a arrow. That means the reaction is not equilibrium. It's not, can't attain equilibrium, state of equilibrium. Okay. So I want to talk more about these arrows. So if you have the arrows that are aft, so what we mean is here is that the both forward and the backward direction can take place simultaneously. So I hope that what I'm demonstrating, you know it. Okay. So I can move to what we call the factors affecting the state of balance. I believe you are getting my discussion clear. Factors affecting the state of balance. Here we have Here we have the pressure, we have temperature, we have concentration, and we have the catalyst. Now, I want to start with concentration, number one. Concentration. How is this concentration affecting the state of balance or the equilibrium, state of, equilibrium. So how is this concentration affecting equilibrium system? So, for example, let us use, for example, neutralization reaction, where you have a base, that is sodium hydroxide, reacting with hydrochloric acid to form sodium chloride plus water. This reaction is a neutralization reaction. I repeat, if you have, for example, sodium hydroxide, a base reacting with an acid to form sodium chloride plus plus water. So this means the reaction is neutralization reactions. So I want to write ionic equation here. Ionic equation. So for you to form water, because neutralization is much of forming water and a solid. So I want to write ionic equation. My ionic equation here is you have OH, hydroxide ion. You know how is hydroxide ion written? Plus hydrogen ion from an acid to form water. Hydroxide ion from the base plus hydroxide ion from the base and hydrogen ion from an acid to form water. This is ionic equation in neutralization reaction. Now, what do I mean here by concentration? How is it concentration? How does concentration comes in here? I want to talk about concentration. We have heard about 2 molar. You have heard about 0.5 molar of hydrochloric acid. You have heard about 1 molar of something. So this is concentration in moles per liter. But I don't mean here I'm going to use molarity or mathematics. I'm going to use the knowledge from concentration to explain the effect of adding more OH to the equilibrium system. So if you add sodium hydroxide, for example, to the equilibrium system here I mean is hydroxide ion reacting with hydrogen ion from an acid to form salt and water. So salt here I mean is sodium chloride and water. Ionic equation is hydroxide ion plus hydrogen ion to form water. So what is the effect of adding sodium hydroxide on the equilibrium system? The equilibrium system I mean here is hydroxide ion plus hydrogen ion to form water. What is the effect of adding sodium hydroxide here? The effect comes here now. It means that you are adding more OH to the equilibrium system. When you are adding more hydroxide ion to the equilibrium system, it means that you are removing hydrogen ion from the system. This means hydroxide will be much higher than hydrogen ion in the system. Therefore, it will dominate hydrogen ion. And this forms more water because the concentration of hydroxide ion is higher than that of hydrogen ion in an acid. So it will remove, because now the concentration of OH is high than the hydrogen ion, the reaction will the equilibrium will shift forward to form more of water. I repeat, if you add sodium hydroxide to the equilibrium system, what it means here is that you will increase the concentration of hydroxide ion, and this therefore will enhance the equilibrium system, shift forward. What if you have you add more hydrochloric acid to the equilibrium system? What happens? When you add an acid to the equilibrium system, you will add the concentration of hydrogen ion in an acid. So hydrogen ion will be higher than hydroxide ion. And this one, if imagine the hydrogen ion is higher than the hydroxide ion, this means that the ion will remove the hydroxide ion from the equilibrium system. And therefore, the equilibrium system will shift backward, and more of hydroxide ion and subsequent hydrogen ion will be formed. So this means that if you had HCl, there will be high concentration of hydrogen ion, and therefore hydrogen ion being higher will remove will remove hydroxide ion in the system, and therefore water on the right hand side will come back to neutralize that acid, So you will form the equilibrium will shift backward. I want to give more example about on concentration. The another example I can give here is bromine water. You have bromine water, you have bromine gas dissolving in water. You form, I wish you write this one down. I wish you write this one down. If you can get me. If you have bromine gas, right? Bromine gas is a gas, is a molecule. So you have bromine gas dissolving in water to form OBr negative, that is isobromide, that is OBr charge plus bromine, another charge, that is bromide, then plus hydrogen ion, I repeat, you have bromine gas. Bromine is a molecule dissolving in water to form OBr charge negative plus Br charge negative again plus hydrogen ion So on the side of bromine gas dissolving in water, say it is yellow orange. It is yellow orange. You write bottom there, this yellow orange, or you can just say orange. And then on the side where you have OBr, O is oxygen, OBr charge negative plus Br, another charge negative, plus hydrogen ion, right, colorless. On the base of it, light colorless. All those charges are colorless. All are colorless. So that means they are changing from orange to colorless. So I want to explain something here. What is the effect of adding sodium hydroxide to the equilibrium? Okay, after writing that equation, make sure you write the signs of equilibrium. So what is the effect of adding sodium hydroxide here? The effect of adding sodium hydroxide will produce more OH to the equilibrium. The effect of adding sodium hydroxide to the equilibrium will affect water, because sodium hydroxide contains high concentration of hydroxide ions. So when you add sodium hydroxide to the equilibrium, what happens? The concentration of OH in water will increase, and therefore this OH will dissolve high amount of the gas, and the gas is bromine gas, and therefore this equilibrium will shift to the right or will shift forward to form more of OBr plus Br plus hydrogen ion. I repeat, if you add more sodium hydroxide to the equilibrium system, sodium hydroxide will add more hydroxide ion to water, because water contains hydroxide ion or ion. So if what happens? The water now is higher than the gas, and the gas is bromine. So because the water is high, will dissolve this less gas, and therefore the colorless liquid will be formed. This means the equilibrium will shift forward. Let's come to this again. What is the effect of adding hydrochloric acid? What is the effect of adding hydrochloric acid to the equilibrium system? The effect here is, if you add sodium, hydrochloric acid, you will get much of hydrogen ion added to the hydrogen ion on the equilibrium system. Remember, we have hydrogen ion on the equilibrium system on the right hand side. So if you add HCl to the equilibrium system, HCl contains hydrogen ion. This hydrogen ion, with the hydrogen ion on the equilibrium system, will increase the concentration of the colorless liquid. And this colorless liquid now will form back water and the gas. Water and the bromine gas. Okay? So if you add hydrochloric acid to the equilibrium system, this means you are adding more for hydrogen ion. You are adding more of hydrogen ion. This hydrogen ion together with the hydrogen ion in the equilibrium system will make the colorless solution more concentrated, and therefore the equilibrium shift backward. Now, that is concentration. This observation is in agreement with what somebody we call Richardaria principle. This concentration is in agreement. This observation is in agreement with somebody, a British known as Richardaria. Richardaria, we call it Richardaria principle. If you like, you can say Richardaria, but you cannot be asked. It's not biology where you will be asked to write the name. The name is your. If it is exam, you are just told state Richardaria's principle. Richardaria principle said that if a change in condition, this condition, I want to explain the stating. Condition here is the parameters we have, all of variables we have, that is pressure, temperature, concentration, and catalyst. If change in condition is applied to a system in equilibrium, the system behave in such a manner that it can oppose that condition. I repeat, if the change in the condition is applied to a system in equilibrium, the system behave in such a manner that it can overcome the condition. That means it opposes the condition. So that is according to Richardaria's principle. So that principle, bear it in mind, is very important because through it you can be able to understand how concentration works, how temperature works. So this person said is a British scientist, who's a chemist, who said that if you have a change in the condition applied to a system in equilibrium, the equilibrium changes so as to oppose that condition. If you add, for example, I've said concentration to a system of the equilibrium, for example, adding sodium hydroxide to the equilibrium system of bromine and water, you will realize bromine will add, sodium hydroxide will add more of hydroxide ion to water, and this water will be higher than the gas. This one will shift the reaction, the equilibrium forward. So that is according to Richardaria's principle. So I want to move to temperature. Temperature as another factor affecting concentration. Temperature as another factor affecting. Temperature as another factor affecting the equilibrium system. So in class we had discussed about temperature as affecting the exothermic and endothermic reaction. So you can just know that the temperature is affecting this when you see enthalpy at the end of the equation. When you see enthalpy here, I mean, is that when you have, for example, you have ammonia plus, okay, let me use, for example, you have hydrogen gas plus nitrogen to form ammonia. At the end of the equation, you have change in H. That means enthalpy. Enthalpy of a reaction is negative 92 kilojoules per mole.
Malim.
This means, yes?
Yes, Sumaya is asking, you repeat what you said of hydrochloric acid to bromine water.
Hydrochloric acid to bromine water, yeah, I want to repeat this. Hydrochloric acid is an acid. Okay, what gives hydrochloric acid an acidic property is hydrogen ion. Hydrogen ion gives hydrochloric acid an acidic property. So if hydrochloric acid is added to the equilibrium system, so what happens? The hydrogen ion from an acid will increase the concentration of hydrogen ion in the equilibrium system. Remember, hydrogen ion is on the right hand side. So the hydrogen ion from an acid will increase the concentration of hydrogen ion on the equilibrium system. Therefore, if hydrogen ion is increased on the equilibrium system, what will happen? What will happen is that the colorless solution on the right hand side will be higher than the left hand side. So what happens is that since the hydrogen ion is higher on the right hand side, it will make the equilibrium shift backward so that water is formed. The water and the hydrogen ion is high. I repeat, if if hydrogen ion from an acid is added to the equilibrium system, so this hydrogen ion will increase the concentration of hydrogen ion on the right hand side. Okay, so the colored solution will be of high concentration than the orange solution. So the equilibrium will shift backward to form more of orange solution. Hope you can get me clear. Do you get me?
Yeah, okay, yeah, okay. Continue.
Okay, can I move forward?
Yes?
Can I move forward? I'm saying, can we proceed?
Yes, you can proceed.
Okay, right. I want to move to temperature. Temperature affect increase in temperature favors the increase in temperature favors exothermic reaction. Increase in temperature favors exothermic reaction. And how do you know if the reaction is exothermic? Who can answer that? How do you know that the reaction is exothermic? For example, you have hydrogen ion plus, I'm sorry, if you have hydrogen gas reacting with nitrogen to form ammonia. At the end of the equation, you have change enthalpy is negative 92 kilojoules per mole. Negative 92 kilojoules per mole. That's enthalpy. So how do you know that this reaction is exothermic? You can answer that? Fatuma, how do you know that this reaction is exothermic? Is exothermic. You have, for example,
it loses heat to the environment.
Yeah.
It loses heat to the environment.
Yes, eh? Of course, there is emission of heat to the environment, or there is heat loss to the environment. That's exothermic. But when you have an equation to know the reaction is exothermic, you check on the enthalpy change. If it is negative, this means the reaction is exothermic. For example, hydrogen gas plus nitrogen gas to form ammonia, and at the end of the equation you have heat change, or enthalpy is negative 92 kilojoules per mole. So this means the reaction is exothermic because the enthalpy is negative. Are you understanding? Can you get me, Sumaya? Do you get me?
They can get you. They can get you.
Yeah, right. So if I've said, if at the end of the equation you have heat change or enthalpy is negative, for example, a nitrogen gas reacting with hydrogen to form ammonia. So at the end of the equation you have enthalpy is negative 92 kilojoules per mole. Negative 92 kilojoules per mole. So you can know the reaction is exothermic. The reaction is exothermic because the enthalpy is negative. There is heat loss to the environment, as Fatuma said. So I want to talk something here. If you see the reaction hydrogen plus nitrogen to form ammonia, and at the end of the equation you have enthalpy that is negative, this means the reaction is exothermic. That's what comes into your mind. The reaction is exothermic. So what is the effect of increasing temperature here? The effect of increasing temperature will ensure that the equilibrium system shift backward. If the temperature is high, the temperature is increased, what happens? The equilibrium shifts backward because the temperature is too much. That is that's when you check on the enthalpy at the end of the equation is negative. If you are asked, explain the effect of increasing temperature on the equilibrium system, what you say here is that the increase in temperature favors exothermic reaction. Increase in temperature favors exothermic reaction, and therefore to the equilibrium system, the equilibrium shifts backward, and and more of hydrogen and nitrogen gases will be formed. That's when the reaction is exothermic. I repeat, if you increase temperature, increase increase in temperature favors exothermic reaction, and therefore, if the temperature is too high, what happens? The equilibrium shifts backward. Backward means ammonia will be forming the reactants, and the reactants is hydrogen and nitrogen. What if you reduce temperature? What if you reduce the reduction in temperature? What if there's a reduction of temperature? Reduction of temperature favors endothermic reaction. Endothermic reaction. So again, okay, I want to bring into attention here that if exam comes, sometimes these examiners may not ask you explain the effect of increasing temperature, but they can just say explain the effect of temperature on the state of balance on the equilibrium system below. Examiner may not say specifically explain the effect of increasing temperature to the state of equilibrium, but they can just say explain the effect of temperature on the equilibrium system. So here, now you have to talk more about increase and decrease on both sides. You talk about increase in temperature and decrease in temperature. Increase in temperature and decrease in temperature. So if you have checked on the equation and you have realized that at the end of the equation, there is a negative enthalpy. There is negative enthalpy. So this means that if you increase temperature, this temperature favor exothermic reaction, and this exothermic reaction normally favors backward reaction, and therefore the equilibrium shifts backward, and the more of hydrogen and nitrogen ion is for and more of hydrogen and nitrogen gas are formed from the ammonia. So I know in the future some of you will work in other process, that's manufacture of ammonia. So when you will be working here, ensure that you don't use much of temperature, because much of temperature favors exothermic. Here that now you will not be forming the product, but you will be forming the reactants. So you must know how to adjust the temperature appropriately. So you have to say increase in temperature favors exothermic reaction, and therefore I want to talk about endothermic reaction. How do you know whether the reaction is endothermic? You can check on this when when you see enthalpy is positive. For example, you have, I want to use the same equation, hydrogen gas plus nitrogen gas to form ammonia. At the end of the equation, you have enthalpy that is positive 192 kilojoules per mole, positive 192 kilojoules per mole. So this equation means that the reaction is endothermic. The reaction is endothermic. So according to this equation I've said here, it contradicts the first one. It contradicts the increase in temperature. It contradicts the exothermic reaction. Here again, you say increase in temperature, if the reaction is endothermic, increase in temperature favors endothermic reaction. So if you increase temperature again here, you will form now ammonia. If you increase, if the enthalpy is positive at the end of the equation, you have to increase temperature so that you form what? You form the product, which is ammonia. But if you reduce temperature, this temperature you have reduced will favor the backward reaction. So I want to talk more about this. If the equation at the end of it there is enthalpy that is positive, this reaction means it is endothermic reaction, and therefore the equilibrium, if you increase temperature, this temperature will favor the forward reaction. Yes?
Mwalimu,
Yeah.
you are remaining with 5 minutes. So you can ask questions. You can give them time to ask questions.
Okay, right. It's okay. So I want to end by saying, if you have increase in temperature, you can say that if the temperature is increased, at the end of the equation, you see enthalpy that is positive. Therefore, if you increase temperature, the forward reaction is favored. Is the forward reaction. Now you will form, there will be high yield of ammonia. There will be high yield of ammonia than the backward reaction. When you reduce the temperature here, there will be high formation of nitrogen and hydrogen gas. So hope that up to that point, your students, you can get me clear. And if you are confused somewhere, you can ask. You can ask if you are confused somewhere. So I want you to write this one down. Explain. Write this one down, please. Write this down.
Question.
Explain the effect of temperature. Write this one down. Explain, that is number one. Explain the effect of temperature on the following equilibrium system. Explain the effect of temperature on the following equilibrium system. Sulfur oxide plus oxygen gas, you form sulfur 6 oxide. That is SO3. SO2 plus oxygen, you form SO3. Then at the end of the equation, write heat change is negative 92 kilojoules per mole. I repeat, explain the effect of temperature on the equilibrium system. Then the equilibrium here is SO2, that is sulfur oxide, plus oxygen gas, you form sulfur 6 oxide. Sulfur 6 oxide. So I wish you to stop there. Then we shall proceed next time.
Malim, heat change.
We start from there tomorrow.
Malim, heat change.
Yes.
Heat change.
Yeah. Someone having a question?
The heat change, Malim.
Heat change is negative 92 kilojoules per mole. So we shall say start from that tomorrow. Have a nice day.